Welcome everyone to today's webinar for part 3 of our Demystifying the PCR LCA EPD creation process, standards, tools, and trends. So in our part 3 today, we're going to be talking about data and carbon calculator tools. Why do they exist? What are they? And how do they work? So if you've been attending part 1 and 2 of this series, you'll see that the context is that not long ago, most people didn't even know what the acronyms PCR, LCA, EPD meant, let alone ever heard of them before. And now that decarbonization has practically become a household word, everybody is trying to figure out, what does it mean? How do you do it? What do I as an organization need to get happening? And the whole field of life cycle assessment was once largely comprised of academics. There were very, very few life cycle assessment tools. The venture world never thought that was an interesting vertical to invest in, and all of a sudden, that has all changed, and the entire industry is scrambling to train up lots of people, build new tools, teach people how to use them, and really make sense of this whole new world of decarbonization. And so this series has really been about going deep into each of those acronyms to understand the creation process, starting with the PCR, how the PCR drives the LCA, how the LCA drives the EPD. And so this third webinar is, now that all these EPDs have been created and are being continuing to be created, how are they getting used in the new tools that are being created for people to use? So with that, I'd love to introduce our guests for today. I think you're all going to turn on our cameras. Is mine on? And now it's off?
Just turned it off, Terry. You were there before.
Okay, here I am. Stacy and I like to do this like really silly girl thing and wear matching hats when we do webinars. Thank you for the hat, Stacy.
You're welcome.
Jack will get his when he graduates from the webinar. So for those of you attending, thank you. A couple things. This webinar is being recorded. You will automatically get the recording in the next day or two. If you would like to get a copy of the deck, you can request that when that recording comes to you. Any questions you have, please put those into the questions panel. We will be monitoring that questions panel throughout the webinar, but any question that you ask that doesn't get answered, we will definitely follow up, get that answered, so don't worry about that. And lastly, please, if you have a question, I'm sure there's other people on the webinar who have the same question. This stuff is technical, it's new, lots of terminology. We're all only getting good at explaining it ourselves. The three of us coming together, we have a lot of content that actually nicely, there's a lot of overlap. So maybe hearing things a few times from different people will help drive things home. But thank you for coming, and let's get started. So what I'm going to do first is I'm going to recap some of the key concepts from the first two installments. Again, the purpose of the webinar, what's a program operator, purpose of PCR, what's a program operator, how do PCRs drive LCA and EPD creation. I actually took out the manufacturer's journey just now to try to get the content to fit in an hour, but we can always get those questions answered. And then I'm going to turn things over to Stacy and Jack, where they're going to walk through all of the content that we promoted about how are the EPDs getting used, where is the data coming from, generic versus generic LCI data versus data from EPDs, the different tools that exist, the whole ecosystem of people using the data, and more. And then finally, in the end, I'm going to give you a quick sneak preview into the Transparency Catalog now with Project Builder, which is now another tool in the ecosystem that will help people very simply select low embodied carbon materials in early stage design without actually having to build models. So moving right ahead, a little bit about us. If you're new to Sustainable Minds, we are the only end-to-end product transparency solutions provider in the market today. We are a program operator. We develop PCRs, publish EPDs, we deliver LCA and material ingredient disclosure services, and we publish innovative digital reporting tools, environmental reporting, material health reporting. Our whole premise is that environmental and material reporting are just another set of performance criteria that manufacturers need to be able to speak seamlessly about when they're marketing and selling their products, because people are using those criteria to select products to get into projects. Just very quickly, we launched the Transparency Catalog in 2016, thinking that there would be a market for people looking for high performance, meaning low embodied carbon, healthy materials, that there would be a market for people looking for those products, and we wanted to reward manufacturers who are actually going the distance to make lower carbon, healthier products. When we launched the Transparency Catalog in 2016, there were only 350 manufacturers anywhere in the world making products for the North American market who had published EPDs or material ingredient disclosures. Today, as of July, we have over 2,000, almost 2,200 manufacturers and industry associations across 28 master format divisions in over 1,300 sections. And because we're a program operator, and we've been in the LCA EPD business pretty much since it became a thing here in North America, we have been aggregating all the EPDs from North American program operators, making them findable by type, as well as aggregating all the material ingredient disclosures as well. We're super excited to be able to say that we are now used by all of the top, as indicated by ENR, all of the top green design firms and all of the top green contractors by sector use the Transparency Catalog simply because it is such a robust resource, easy to use, and of course it's free. Okay, so the purpose of a product category rule and why it's critical they get created the same way, and this is the theme of the whole series, why it's critical that PCRs all get created the same way. So if we look at the EPD creation process, it starts with a whole series of standards that drive LCA creation, PCR creation, EPD creation. All those standards get documented in a program operator's technical program to drive the creation of a product category rule that's created with a committee of industry stakeholders who are knowledgeable about products in that category. The rules in the PCR stipulate how the LCA gets done. And in that, it includes requirements about the types of data, primary data, whether it's generic life cycle inventory data or it's supply chain specific data. And then the PCR also stipulates the content requirements for what goes into the environmental product declaration for that product category. The beginning, front to back, a PCR can take 3 to how many number of months, depending on how the program operator runs the PCR process. An LCA can take 2 to 3 months, maybe 4 or 5, depending upon the scope and whether you have to go upstream to suppliers for data. And an EPD can then, is the shortest part of the whole process because all the work has been done in the LCA. The EPD is essentially a template from the program operator and any requirements in the PCR, but it's not unlikely to be spending anywhere from 3 to 8 months doing an LCA EPD project with or without layering the PCR on top of that. But now that manufacturers have spent so much time and money and effort being transparent, the next step in the voyage of EPDs is they're getting added to places like the Transparency Catalog, other EPD databases, carbon calculators, and whole building LCA tools. And that's what Stacy and Jack will be talking about today. Now, everybody on this call, I'm sure, knows about the EPA grant program and that those grantees have been announced. You know, it is game on. People can't get enough EPDs at this point. Everybody is on board, policymakers, industry, rating systems, and industry associations, as well as major purchasers, all demanding proof. And so, again, now you know it all starts with the PCR, because this increased demand for EPDs is requiring EPDs with cradle to grave scope. In the past, many PCRs have just been cradle to grave. Doesn't really give you the whole picture. And so this is a snippet from the EPD assistance program in the IRA, looking, stipulating we're going to want more EPDs from all life cycle stages. And to do that, more PCRs are going to have to be created with cradle to grave scope to keep pace with demand. And now you know EPDs are powering other tools to make important decisions. And so the data has to be standardized and reliable, which means it all starts with the PCR, and PCRs all need to be created the same way. So back in 2022, folks at the American Center for Life Cycle Assessment spent several years creating the new ACLCA PCR open standard. I was actually one of the co-leaders and editors of this project. We spent 2 years putting it together to get out ahead of this demand for standardized PCRs. And we created a very easy to use and understand set of tools, ultimately, where these are checklists for all the people involved in creating a PCR. These are the things the program operator has to do. These are the things the committee needs to do. These are the things that the reviewers need to do. It's made up of a whole set of criteria, and the criteria contribute to different EPD use cases, because what we determined was people are using EPDs for different purposes. Largely today, EPDs are being used just to report transparency, but as we go forward, increasingly, and again, Stacy and Jack will be talking about this, EPDs are being used for public and even private procurement, and EPDs are being used to create background data that drive the creation of new EPDs, so that supply chain ingredients get standardized background data so that everybody can use that same data when they're working on their particular product-specific EPDs. So it was great we got the ACLCA open standard done in advance of the IRA and EPA grant program and their lower embodied carbon labeling program, because when they did their research looking to how do we standardize PCRs so that we can know what PCR is actually reliable to make EPDs that we can rely on to make procurement decisions, they took the ACLCA open standard into their consideration and ultimately adopted it largely in total and added 11 additional criteria that would help standardize the way carbon gets accounted for. And so this is still in draft. They'll be coming out with the next version soon. But we were really excited to update our technical program at Sustainable Mines in accordance with the PCR open standard. We were the first to do that and the first to publish 7 PCRs now in accordance with the standard. And there are a number of other program operators on board now creating standardized PCRs that will produce reliable data that will create EPDs that also are standardized and reliable and are the feedstock that everybody's looking for to go into these tools. If you're a manufacturer and you're wondering if there's a PCR already for you to get started, you can go to the transparency catalog where we've built the North American PCR catalog. All the PCRs are organized by master format, and we last year added a column in the table to start indicating which PCRs are getting created in conformance with the ACLCA open standard. So I'm going to just fast forward because we are running a little bit behind, but this is content from a previous webinar. You will get the links to the previous webinars too. You can also request the decks, but this just shows you how in the LCA, it stipulates the type of data, where it needs to come from. Sorry, this is what's in the PCR. It stipulates all of these things so that in the LCA, these are the rules that are getting followed. Delivers an LCA report. In the PCR, not only are those types of data, the sources, all of those things stipulated, there's use-based scenarios. These are what the PCR committee works out. This is what people are looking for now to be included in cradle to grave PCRs. So this is what's part of the process. And I think probably I've left you a little bit fire hosed, but because not all program operators are using the open standard. It has always been the case that not all EPDs are created the same way, and that will continue to be an issue until all PCRs are created the same way. So Stacy, with that context for manufacturers and program operators, I'm going to turn it over to you.
Great, thanks, Terry. So I'm just going to tell you a little bit about Building Transparency if you don't know first. I'm currently the executive director of the nonprofit Building Transparency. We're a North American-based 501c3, and our mission has been since we launched to provide the open access data and tools necessary to enable broad and swift action across the industry when it comes to addressing embodied carbon and its role in climate change. So we started as the landing pad for the Embodied Carbon and Construction Calculator, or EC3, when it was launched, and wanted to make sure our mission was wrapped around the trust and continually providing that data and that tool for free. And then we were then gifted Tally LCA from Karen Timberlake, which is a whole building lifecycle assessment tool that I'll mention briefly. I know Jack will mention briefly. So really at the core of what we do is digitizing environmental product declarations and LCA data for use in our free and licensed tools, as well as anyone else's. And then I always like to show our partner slide. This is everyone that's supporting us financially or piloting and partnering with us in the use of our tools and data. And it'll hit home, I think, on the next slide, but this is really just to show when we're talking about embodied carbon analysis, life cycle assessment, EPDs, LCAs, and embodied carbon accounting, it really is all hands on deck. There are policymakers, whether they're a private company or a public agency, making the policies that we must meet when it comes to whole building life cycle assessment or low carbon material procurement. And then we have the architects, engineers, and contractors that actually have to do the work to implement those policies. They may even be setting them themselves. There's very forward-thinking firms also in the architecture, engineering, construction space setting their own policies. There's also other tools that need to ingest and rely on data that can be consistent and comparable between the tools that BT offers, that Terry offers at Sustainable Minds, that others offer like Tangible and OneClick and Epic, to ensure that we're sharing the data and we're not trying to duplicate efforts wherever possible, because we don't have time. And then the manufacturers and industry orgs, as Terry mentioned, they're the ones that have to provide the data. And it's important that we are working with industry organizations and manufacturers as we look at the requirements we're putting on them for this data, how it is filtered and digitized and sorted, and then how it's actually translated into things that are useful as data points for policy and reporting. So this is a slide that I used in a previous presentation that I gave that just is trying to visualize what I had just said. But really, it's a loop. It's circular, because as owners and policymakers translate policy into something that the architects, engineers, and contractors have to then implement and comply with, they then request the data from the manufacturers, and it goes back and around all the way back to the beginning to inform more policies or more stringent policies. So it really is all hands on deck. We all play a role. I'm just going to do a high level kind of, what, when. I know Jack's going to dig into more of the details of the tools, but really when we're thinking about how architects, engineers use the tools, they're the ones that are designing and specifying. So they need to have, generic directional data that they can use to benchmark and assess systems and design choices early, from concept to schematic. And then as they get into design development and construction documentation, that's when you kind of switch over into looking at products and picking which products you're going to meet or specify within those systems that you've designed. So there are tools along this trajectory. Epic and Tally are more of the whole building lifecycle assessment tools. OneClick also does that. And then you move into more EPD related tools or focus tools, which OneClick and EC3 both provide. And then a little bit further down the chain, once you get into construction documentation and beyond, that's where you are using EPDs to confirm what you've purchased and do as-built accounting that many of the private sector and now the public sector policies are asking for, is really what did you buy and how much did you buy. Then on the manufacturer side, this is just a call out to the Materials Carbon Action Network that Building Transparency hosts. We do need manufacturers to understand what's being asked of them and to work together to provide this information in a way that's consistent and comparable following the standards, but also work with each other to educate others that are manufacturing products as we all try to learn this as fast as possible to meet the requirements. All right, so I'm going to just talk briefly through this process again. This is just another visual to kind of get that cemented in your brain that it takes everyone. There's things that we all need to do. And to do the work, we really do need the motivated stakeholders, which we now have. I can say that with assurance, with the policies on both the private and the public side. We need education, and this is coming from folks like the Carbon Leadership Forum, webinars like this. We need those influential policies that are now being created by the stakeholders. And then the bottom thing is what I'm going to focus the next few minutes on is the underlying foundational requirement of data transparency and robust carbon accounting via EPDs. Just a little bit about how my analogy that I use when I talk about this. I say this in all my presentations. This is a quote my mom always used to say: life's like an onion, you peel it back one layer at a time, and sometimes you weep. I really like to say embodied carbon is like an onion, especially when it comes to the data. You peel it back one layer at a time, and sometimes you weep as you realize there's just even more to understand and do. But we all need to be digging into this together, putting on the goggles, letting us shed some tears and get to that center of the onion over time. And we're getting closer. So when it comes to the data, everyone needs the data. We both need both types of data. And really when we're talking about this data, it's either generic material data through life cycle assessments that are giving you regional emissions factors for different materials that you can use in a harmonized data set as you're looking at whole building life cycle assessment. Again, the building level early design optioneering to get to some numbers that help you make informed decisions and benchmark. And then as you move into product to construction documentation and beyond, I didn't have enough room on the slide. That's really where you get into the product specific data and EPDs that are truly necessary to do the documentation and as-built accounting that the policies are requiring. So again, generic LCA data to product specific data, both are important. And the other thing to note about this is what Terry had mentioned. This is a kind of technical wonky slide, but it's important, I think, that there are layers to this data, and at every step of the way, starting at the bottom from the unit process data, this is where you're getting to data sources like EcoInvent or Gabi or the US Lifecycle Inventory, all the way up through the LCA platforms that take that unit process data and have methodologies for how they leverage it, either conglomerated together or separately, into product-specific lifecycle assessments or generic lifecycle assessments that then get put into generic databases or get pushed up to program operators who then have thrown product category rules across all of these different programs that then push up to product-specific EPDs. So you can imagine the different ways that these emissions factors are created all the way at the bottom, how they're mushed together, how they're then generated into data sets, how they're then turned into environmental product declarations with differing rules, how that uncertainty around the data can just grow. So it's important that we know this, but it doesn't mean that we shouldn't start using the data now. I have to say that. We just have to have the awareness. I'm going to focus on environmental product declarations and not generic data. I could do a whole other presentation on generic data and projects we're working on there. But really with EPDs, it is trying to get to those metrics around all sorts of impacts, but really the carbon emissions is where people are focused today. and they can be cradle to grave or cradle to grave, as Terry mentioned. But when we start to look at EPDs, this is really, I think, repeating what Terry said, but hopefully in a way that's memorable for you. When we have the standards at the bottom that set the requirements for the life cycle assessments and the generation of product category rules, this is what's currently happening. There will be different Part A's and Part B's that the program operators will make with different rules in terms of underlying data and methodologies and other things that then turn into EPDs across the top that are truly not comparable. One of the things that I think EC3 has tried to do with our EPD database and tool is enable the ability to filter by product category rule by digitizing the PCRs into the database and enabling folks to at least filter down to EPDs that are under the same PCR. But in an ideal world, and what we really need to start to happen with these policies that are coming is the move to more comparable EPDs. And that really means that you've got to go up the chain. You can't stop there. You have to keep going to Part A PCRs and Part B PCRs that are being shared and standardized, sorry about that, to get to comparable EPDs. So again, these are more comparable. They're not perfectly comparable. We're all on this journey together, but this is really an important step in what's happening right now with the policies that are coming out for us to get to data that we can really trust. Just one little analysis on this. I know I'm probably running over time, so I'll try to be quick, but an example of why supply chain specificity matters in these requirements that we're seeing is that if you think about a concrete EPD manufacturer who's using a cement supplier that has an EPD, so you're using supply chain specific information around the carbon content of the cement going into your concrete mix, their number is going to be more accurate because they're using specific data. That cement supplier's number might be higher than the average emissions factor that's in the EPD or is allowed to be used in the EPD today. So manufacturer B might have a cement supplier that doesn't have an EPD. They use the industry average cement number, which is an average, and there's an unknown impact of the actual supply chain specific cement that manufacturer B is buying. So there's a range of what that manufacturer B's EPD really is, because it's average data compared to you knowing what supplier manufacturer A's EPD is telling you, but their number might appear higher because that average is being used down below. So the specificity part gets really important when we're trying to make procurement decisions based on the information in an EPD. Let's see if I'll go to the next slide. Sorry, it's a little laggy. This is just a way that we try to disclose this within the EC3 tool. This is looking at a EPD on the left. It's a cubic meter of concrete, and you'll see that it's only manufacturer and plant specific. This EPD is not product specific. It is not supply chain specific. So you can see we apply an uncertainty factor, what I call blue squishy stuff, around the declared number, just to try to help people understand that there is some uncertainty, there is a variability in the number disclosed. On the right, there's an EPD that has manufacturer, plant, product, and 89% supply chain specific information. This is where a cement EPD is being used within a concrete EPD. And you can see that that uncertainty gets down to a very small residual amount. So anything that we can do as an industry to educate ourselves about this and try to find ways to disclose uncertainty, but also push to that future state of really comparable, really accurate EPDs. Let's see if it'll flip to the next slide. Oops, I can go back. There we go. So as Terry mentioned, we're seeing more and more policies to adopting EPDs in decision making. It's happening at all the different levels of government. It's also happening in the private sector. And we're also seeing a move to whole building life cycle assessment policies where that generic data also becomes important. And sorry, the slides are being a little laggy on me. We are seeing those different guidelines that Terry mentioned, whether it's the EPA putting out their product category rule guidelines on top of the PCR guidance from the LCA, or the fact that the EPA is actually now sitting on PCR committees, which is very important to have the role of policymakers filled on those committees making the rules. And so how can upcoming policy support and facilitate the production of high quality EPDs? It's the carrot versus the stick. We're seeing this now with the EPD grant program that has rolled out millions and millions of dollars to help create EPDs, the PCR guidelines that the EPA has given, but really it's to incentivize or require EPDs that are plant specific, supply chain specific, and come from a single high quality PCR. And the PCR and standards influence by funding high quality PCRs and funding and supporting high quality background data. All of this is happening right now. It's not a wish list. Now it just needs to be executed and built on top of. And the future of EPDs and private and public policy really comes down to this. This is where we're flipping the uncertainty on its head and reducing it by going from type 3 EPD requirements to harmonized standards and PCRs to requiring EPDs that are manufacturer plant product and supply chain specific, all the way down to requiring the same underlying data sets that could, hopefully are public, that can be used in the generation of all the different life cycle assessments.
Hey, Stacy, can I jump in for one quick second? There already has been a question sent in to ask you to define uncertainty. So maybe go back to that slide and just put a finer point on how do you define uncertainty in EPDs?
Yes, and I'm trying to figure out, I guess it could be this one, but really uncertainty is another word to me for variability in the data and in the specificity. So if you think about, I guess if I go back to I have to go way back, Terry, to the one that's got all the different steps. I'll try to be fast about it.
No, that's okay. You have time.
Okay. And I can also, we can put the link in the chat to the way that building transparency has looked at uncertainty historically in the very technical weeds, if anyone's interested in that. But if you start at the bottom here and you go up, and a good example at the kind of unit process level is energy grid data. If you look at the numbers that are presented by EcoInvent and the US LCI or GABI, the emissions factors for an energy grid in a certain region, they can be different by a magnitude of 5 or 10 in some cases. And so if that's a number that's being used at the very bottom of generating a life cycle assessment, that energy grid number is being used in the life cycle assessment, the dependency on which one you use is going to create a difference or a variation in the results, which gives you an uncertainty bar on the number if you're comparing one to the other. So it just aggregates all the way up. Different LCA platforms might mush together a couple of data sets that you see down below to get to emissions factors they use. There's different ways, methodologies of how things are kind of put together. They might generate their own emissions factors based on machine learning and AI. And all of those then give you LCA results that have all of that variability built into it. So it's multiplying itself to create larger and larger ranges, all the way up into, again, the PCR requirements that might not dictate underlying data sets, so they can use whatever one they want down there at that bottom level,
So I'm glad
or
you
might
brought that
have
up,
different
though,
ranges.
because that's actually part of the ACLCA open standard.
Correct.
For PCR, for program operators and stakeholders to identify the background data sets for inputs that are significant. And I forget what the percentage is, like over some percent of the input in a life cycle stage, but to identify those inputs that are significant and to stipulate the data sets that get used so that everybody is using the same background data set for that input. And so the struggle here, just so the attendees understand, is that some data sets are free, which is great, and some data sets are not. And so it's a struggle for PCR committees to decide whether they're going to stipulate the use of a background data set that everybody has to buy. That's kind of, nobody's really on board for that except the folks who are going to benefit from getting their data sets bought. And so a lot of the money that was disseminated and included in the grant to the American Center for Lifecycle Assessment was to invest in building background data sets that will be freely available, that can be used to start to reduce uncertainty in key unit processes.
Yeah, just a note on that, Terry. I think even a move to require the disclosure of the data sets used is a step that is an improvement on many product category rules out there. And that at least, just like the product category rule label or layer would allow filtering and sorting to ensure you're comparing EPDs that have used the same data set. So it gets into how we frame all this from requirements into digital schemas into databases to enable comparability at whatever stage of the process we're at currently, because it is a journey. We're not at the end yet.
No, well, nope. All right, you were just about to wrap up so we can get over to Jack. So
yeah, I'm going to push the button to see if I can get all the way down to the final slide, because it really is like the point of what we just said, which is that we are, we are on this. This is a slide from Michaela, one of my employees on VT side, but it's this pipeline. We're getting there, but we have to continue to do all of these steps and to become more aware, even though it's a whole conglomeration of acronyms we all have to learn. Be aware of how to apply certain rules, what to advocate for, whether you're an architect, an owner, a contractor, or material manufacturer, because we all need to be advocating for the same things. And that's really what we're trying to educate you on in this session. With that, over to Jack.
Thank you for that already vigorous discussion, and there will be more. And over to you, Jack.
Awesome. Great to be here. Thanks for teeing everything up, Terry and Stacy. As Terry mentioned at the beginning, I'll talk through some similar topics, but really come at it from, we'll say, my role as a practitioner, as the director of climate strategy and architecture firm in San Francisco and Seattle. We also participate in tool development and have some tools out there in the industry. Epic, that Stacy mentioned, is one of our tools. But I'll try to do some sort of demystification and talk about the way these things really affect the practice that we have in our firm. So, giving away the ending. First, I'm going to go through some common data sources that we see in decision making. The first that isn't LCA, you might typically call process-based data because it's a description of the specific processes that led to a product's creation. We also, though, in our work, deal with spend-based data. Maybe people have heard of this. It's what's used in GHG protocol reporting. Most large companies use spend-based metrics to understand their organization level carbon footprints. An example of this might be that we spent $100 on concrete. There's a spend-based metric that's determined by the sort of economics of concrete in the United States that tells us the emissions associated with this. This is actually, this data gets a bad rap sometimes because it is very low resolution, but it's really good at some things. You can ask big questions quickly. It's really comparable kind of across the whole economy is the power it has. And kind of most importantly, these spend-based metrics do a better job describing variability in these industries than process-based analyses do. For instance, if you are a concrete plant and you make 20 batches and there's a 21st one that fails and you have to throw all that stuff away, the emissions from the failed batch are counted in the spend-based metrics because they count the entire economy within their scope, but it'll be excluded by, say, process-based metrics, at least in part. That makes sort of assumptions about the way a process sort of ideally runs over a typical amount of time. One of the problems we have often in all of this is reconciling our clients' spend-based accounting with our process-based LCA, and that continues to be an area of work for us and others. So to run through, I'll go do these next two together. Generic LCI data and industry-wide or product-specific EPDs really add further specificity to the data and the sources behind it. Generic LCI data lives low on that hierarchy that Stacy showed on the uncertainty slide. It reflects typical impacts, uses the same data and methodology to describe every bit of it. And this is really useful for making comparisons between product categories. So, in a perfect world, we would, we'll say in the world we're living in now, we're going to use generic LCI data to do things like compare a wood building and a concrete building, because the wood and the concrete live in different product categories. Industry-wide and product-specific EPDs, because of the data fragmentation that Stacy mentioned, are really best geared toward making comparisons within product categories. So I'm comparing concrete A to concrete B, or wood from British Columbia to wood, say, from the Southeast United States. As we build the neatly stacked order of data in the volcano that Stacy illustrated earlier, then we can do more. We can more defensively use product-specific EPDs to do a whole building assessment. And in a certain sense, this is actually unavoidable right now. So some of this is just understanding the uncertainty and risks attendant in doing that, and understanding where the data is. But really the goal, where the industry is going, is that we will continue to use product-specific EPDs for doing things like whole building LCA. This word comes up a lot, I think, like uncertainty, which I'll treat a little further in a minute. You see this word harmonization come up often. So I'm going to talk through some of the ways that background data can or cannot be harmonized. The first is that the data uses the same lifecycle impact assessment methodology. In the United States, we have Tracy 2.1, developed by the EPA, I think around 20 years ago at this point, and it helps us understand, say, GWP is a combination of methane emissions, NO2 emissions, CO2 emissions, all rolled into a common metric. The way that gets rolled into a metric, or ozone depletion potential gets rolled into a metric, that's governed by the LCIA. So you might be comparing US data that uses Tracy 2.1 with data from a European product, say from a European EPD that uses something like EN 15804, just another standard that does the same thing. We'll see general alignment around the GWP metric because the factors used to collect everything into that metric are governed by the IPCC, but actually kind of sometimes significant deviation in some of the other metrics. Tracy, the US standards, also sort of desperately in need of an update because the GWP, the global warming potential metrics that they use, are out of date. They use old IPCC data. Another potential mismatch is that you're using different background data sets. Again, this was sort of mentioned by Stacy. You might model the same set of processes in Gabi, one dominant background data set that people use, another in EcoInvent, get the different answers with the same kind of system. Obviously, like this illustrates some of the uncertainty that lives at the core of this data. And finally, harmonized data ideally has the same calculation methodology, but as it stands now, sometimes we'll see different calculation methodologies in different product category rules or across the sort of LCAs in practice. This is things like the assumptions made around recycling or around construction activities, maintenance over time, or when industrial processes have more than one output, the way impacts are allocated to each of those outputs. So really, in our perfect world, where we have that, all the stacked and orderly standards, everything in a building level assessment is using the same LCA methodology, the same background data set, and the same calculation methodology. That helps us roll the data together for use at the building scale. I'm glad the conversation about uncertainty has already started. This is a great little calculator that I would illustrate that comes from building transparency that allows you to really understand the way these different sorts of supply chain uncertainty affect a product level description of GWP. And I think we can contrast this that uses this approach to the sort of uncertainty assessment that we see more typically in whole building lifecycle assessment, which uses sort of a data quality matrix where each data point is rated by its representativeness, geographic representativeness, technological representativeness, to understand how appropriate that data is to the object of analysis. I think one of the takeaways here, right, is that there's no perfect data. There's the data we have and there's the answers we need, and we have to describe that gap between those two things to be able to keep moving these processes forward, even in light of the fact that the perfect data ecosystem doesn't yet exist. So just like there's no perfect data, there's no perfect tool. Tools exist in a workflow. In our work at EHDD, we use many tools to do this sort of work. I'll talk through some of the dominant tools in our processes and others used sort of across North America in this presentation to better understand the way that these data come from all these sources and into the workflows of architects, engineers, and other design professionals. So these are really the ones I'm focusing on and the ones we use at EHDD. Our typical workflow moves from Epic to Tally to EC3, and we're increasingly using one-click where we need to sort of do some data combination that I'll talk about more in a moment. So Epic is the early phase integrated carbon assessment. It's a tool we've developed in-house and offered open access to the industry, now used by around 5,000 design professionals across the United States, and was recently mentioned, something we're really happy about, in the GSA's P100 guidelines for facility decarbonization. One thing I'm going to note on all these tool descriptions is that the impact data is actually just one of many things that they have to sort out. And the larger source of uncertainty actually for project level analysis is the bill of quantities. There's often a lot of, we'll say, uncertainty around the stuff that actually goes into the building, especially at design phases. And this is a major source of variation between these tools. So Epic as an early phase design tool designed to be used before the building, right, has been, before pen has touched paper. We do a lot of interpolation of the bill of quantities based on a large data set of quantities from real buildings. So a typical building, like the one you've described in Epic, will interpolate material quantities based on that and use that to sort of start to populate the model. The impact data we use in Epic, so the say the data on GWP of products, assemblies, and systems, is really meant to describe the statistical distribution of all possible values, because at the early phase, what's most important is setting targets. So if you say you're going to design an envelope with a carbon intensity of 4 kg CO2e per square foot, there's a lot of different ways to do that, but we know from our data set that that is possible today. And then in your later design phases using Tally and EC3 or one-click, you can really tease that apart to figure out the exact products to get you there. And finally, because we take this statistical approach, we use that everywhere. So assumptions are harmonized within the tool, but because of the state of the data ecosystem, we're pulling data from data that under the hood isn't harmonized. This is a screenshot of the tool. One thing to note about Epic, it's a whole life carbon tool, so it actually extends beyond the embodied carbon of materials and also describes refrigerant emissions, energy emissions, and the effects of site and landscaping. So it really tries to take the whole life carbon view to help understand at the early phases what the most impactful decarbonization measures will be. The next tool that I'll talk through that we're also big fans of is Tally LCA. Tally LCA is a Revit integrated software for conducting WB LCA. It has a really actually great interface for determining a bill of quantities from a Revit material. You do user entry for most quantities, and then it has some sort of smart takeoff systems to help understand, say, the amount of wood that goes into a wood framed wall. The background data set is totally harmonized, background data set provided by Sphera that will, I think, continue to evolve, we'll say, into the next year. And this is like this approach to harmonization is great for a tool like Tally, where you're really looking at differences in building systems, massing, shape, and helps you understand what's going to be most impactful at that scale. So zooming into some of the data you put into Tally, you see that you're specifying, say, a material here, but you're also doing things like it's helping you do takeoffs, figuring out how much stuff goes in there. And you have lots of ways to do the takeoff methods to make sure that you're properly translating the BIM data into a useful bill of quantities for LCA. And I accidentally double clicked, so I'm going to lose that. I'm going to go back to EC3. Awesome. So EC3, the bill of quantities is user inputted. If you know it's in your model, you'll put it in there. But if you get to put the screws, we'll say, in your wood stud wall, it won't remember for you. Whereas something like Tally that has its smart lookups will help do some of that filling around the edges. So typically, we'll say in our workflow, we're moving data that we've developed in Tally or in one-click into EC3 at that point, having sort of helped fill all those holes in the bill of quantities earlier on by the time we move it into EC3. Impact data in EC3 comes from the underlying EPD database, which includes data governed by many different PCRs, but it has this great ability to allow you to filter the EPDs to make sure they're coming from the same underlying PCRs. This helps deal with some of those data harmonization issues that are persistent right now in the space. One-click LCA is a tool that we use and others use. It's really a family of tools all under one label that helps with this whole process from early design phases to determining which products to use. So you can use EPD level information, you can use generic data, you can use data you make up yourself. It's a pretty flexible system. And it has a nice system to help sort of have warning flags go up when some of these mismatches are potentially present. So this is a screenshot from one of our projects that I kind of messed up. So you can see some of these things. You see this warning on top. Multiple data sources are used, Eco, Invent, and Gabby. So it's illustrating one potential problem. It has this completeness and plausibility checker that helps you see some of the patterns in the data like that to make sure that you're doing sort of realistic modeling of quantities. So it's a nice sort of like a QA/QC function that helps you as a modeler make sure that you're giving a sort of whole, complete, and robust description of the building and the sourcing of the materials. So that's sort of like the current state of play. As Stacy mentioned, with the pipeline analogy, we're really working towards a better, ideal data ecosystem where we're connecting stronger standards with transparent data all the way forward into the tools that I've mentioned today, into things like benchmarking and reporting databases, to be able to look at those tools and their results across buildings modeled within them. But until we get there, there's some sort of necessity to get comfortable under imperfect circumstances, and realizing that there's sort of no perfect data that exists today. And maybe it's important for us to embrace that now and into the future, right? Each data source is good for some things and inappropriate for others. All data has uncertainty. So rather than sort of having, sometimes I hear a reflexive, well, any of this analysis is garbage in, garbage out, sort of a broad dismissal of a lot of these approaches. Like, let's start to build as an industry some subtlety around what we consider to be good data, and we'll say even like good uses of bad data and bad uses of good data. All of these things are possibilities. There's no perfect tool. They all play a part in a workflow, being better or worse at dealing with different levels of resolution, and really to drive home the point that our best resource in this process of discovery as an industry and really trying to address climate change in our daily work, our best resource is each other. So the forums that exist, like the CLF forum, webinars like this, communities of practice generally in local areas, this really is the place where conversations start that end up having things like policy ramifications. So I'd really encourage everyone listening to get involved, and if you already are involved, get more involved and continue this sort of like a collaboration that's really developed over the last couple of years across the industry. That is one of the major kind of engines pushing these practices forward. So I'll leave it there with about 5 minutes left. Maybe we can take some questions. Thank you all.
There are a couple questions that came in, but what I want to do is before we do that, is just quickly do an overview of what we've been doing here at the Transparency Catalog with the addition of Project Builder and Library, because what you and Stacy did was perfect. It's everything I hoped the story you could tell in this series. And Jack, you bringing it down to the user level, how people are actually using this data to make decisions, shows everyone here who is still here, who hasn't been just like fire hosed to death. It's a lot to understand. It's a lot to know. It's a lot of different tools. How do you really make decisions? And for the manufacturers on the call, they're just wondering like, whoa, how do people use my EPDs to get my products into their projects? And so Sustainable Minds has always been in the business of trying to simplify environmental reporting to make it understandable and meaningful, so it's more accessible to more people. And so what we've done over a number of years by designing Project Builder and Library and integrating it into the Transparency Catalog, we've created this collaborative workflow solution for sourcing high performance materials that meet carbon impact and human health goals in a way that hasn't been possible before. And what we're doing is enabling collaboration across the project's lifecycle to build an internal digital knowledge base for organizations of the right products and materials that meet their design intent, actually whether they're in the Transparency Catalog or not, to build, share, and reuse knowledge, just exactly, Jack, as you had said, that we are each other's best resources. So how do we preserve and share that knowledge? Save time, because this is all really time consuming, ultimately deliver on industry commitments. And what we're all trying to do is build actually higher performing, less impactful buildings. And so as I mentioned, what we've always tried to do is take the data from our partners and not only make it easy to find, but make it easy to use. Again, making it more understandable. So when Stacy was starting out with EC3, we met and I thought, this is great. The EC3 tool methodology has come up with a way to, for better or worse, harmonize EPD data across a reported spectrum, which is how they calculate their industry range and then compare each EPD. And so we said, people really only want to know, is something better or worse than something else? And how much better or worse is it? And so working together with Stacy and her team, we created this custom API for the transparency catalog where we indicate with each EPD that's in EC3 the relative results. So this comparative result we've simply turned into these quintiles, and so it's visual. You can see when you're scanning a manufacturer's product list how that EPD, the embodied carbon of that EPD, how it compares to the calculated industry range of all EPDs in that category. And so because we have this data now assigned to each EPD, users can filter by the carbon threshold that's acceptable to that project, depending again upon the goals that have been set. And so when a user is using the transparency catalog, looking for low carbon materials, they can go into any master format section, and before they even start to look at more detailed sections or brands, they can select the carbon threshold that they want to select to, and then only see those products. And so what we've done is we've saved a user a little bit of time, not having to go into the EC3 tool to run comparisons, because we've already done this for you here. But now in Project Builder and Library, when a user builds a project in Project Builder, they can export it into EC3, where they already will have selected their products, the manufacturer, the brand, the product, the EPD that goes with it, that meets their design intent. And so when they export the project into EC3, all of the EPDs have already been selected. Then they can, as Jack pointed out, enter the bill of quantities for each part of the building and run comparisons and scenarios to see where the greatest impacts are and where those can be improved. So to kind of bring it all together for those of you who are still on, I just want to show you this very short video that shows you how in the transparency catalog now with Project Builder and Library, how easy it is to build projects that meet your design intent and your carbon threshold. So let me see if this can pop up and play. Let's say I'm an architect, designer, sustainability consultant, contractor, or real estate owner. I'm logged into my transparency catalog Project Builder and Library account, working on the commercial office building project in LA, which is being designed to meet carbon reduction targets. Let's start by adding flooring products. I select Add Products from Transparency Catalog, which immediately brings up the selector interface where I can select Division 9, go directly to 0960 flooring, where you can see there's 234 brands and over 2,000 products. It's a very large section. I know that I want resilient flooring, so I'm simply going to turn on only 0965, where there are still 119 brands, 868 products. So to find the lowest embodied carbon products, you can see that tooltip helps explain what all this means. I'm going to select the 20th percentile filter, which leaves me with 6 brands and 12 products. So we're going to do our product research later. I'm going to select all of the products to add to my project, but then I notice that Armstrong Flooring is here at the top of the list. I like Armstrong, so I decide I'm going to go learn about Armstrong Flooring and what they're up to today. When I take a look at the product table in their listing, I can see that I've already selected all of the lowest embodied carbon resilient flooring products. And I can also see that the products I've already selected have stayed with me. And so I'm ready to add all of those products to my project for the rest of the team and me to review and make decisions later. It is literally that easy for project teams to find, select, and get your low carbon products into their projects and libraries. There's so much more to this demo. So let's meet to discuss how we can do this for your products. So I want to thank everyone for coming. We did get to most of the questions that wouldn't take 20 minutes to explain. Jack. We will parse those questions out to those of you who have posed them. And just to wrap it all up, and this is kind of the end of the first stage of this series, again, summarizing why better PCRs are needed to create better EPDs, because it flows all the way down into the tools that people are using to make decisions about products and brands, and it all starts with the PCR. And now you know, not only does it all start with PCR, it means making improved PCRs, it means making improved tools to make it easier for people to make decisions, and it means working with program operators who understand the importance of standardization and digitization. So thank you all for coming, for sticking around. Thank you, Jack and Stacy, for spending your time to put this presentation together. Again, we'll make the recording available in a matter of days, and I wish everyone a fantastic day and rest of the week. Thanks so much.
Thanks.
Thanks, everyone.